Alrighty, this is my first attempt at making a video to show how to align the grating of our diode laser. I first want to say that I do have my laser glasses on, so that's the first start there. I've got the laser set up. I'm first monitoring the temperature of the laser, and for this particular laser the set point is 2.5 volts. And that's where I've got it set. And the cell is on and it's at a set point of 45 degrees, which it's closing in on. And the laser itself, let's get a shot of that. Yeah, not so good. Okay, and I've got the laser on the bench and just shining into a business card here with a CCD camera looking at the spot on there. And now I'm just going to focus on the CCD camera and what's going on there. So back in a minute. Okay, so now I'm just focused in on the CCD video screen, the monitor from the camera. And I'm going to turn on the laser current and watch it slowly increase. And you can see a bright area start to form. That's the laser running as just an LED. As I increase the current, eventually you'll see it change shape there, and that's the laser just starting to hit threshold and starting to laze. Okay. Okay, and I'm going to start with a misaligned grating, so you should see, I hope, a second spot down below on the video card. Boy, maybe I can point to that even. Oops, sorry. Down here is the retro reflection. So that is the retro reflection. And as I move the side knobs, I can make it that move back and forwards together. That's the top knob moving up and down of the grating. And if I move it side to side, I can make them go back and forth. And the goal is to overlap those two spots. And when you do that, you will see a sudden increase. Well, it's a little bit hard to see there, but an increase in the laser intensity. And that's, I've got the laser started to align. Now we need to reduce our laser current to get below threshold, further down towards threshold, so you can see that decreasing. So there is, I'm just hitting threshold as that goes. And now I'm going to adjust that laser again. And it's most sensitive, that's the top knob I'm moving up and down. It's sort of most sensitive there, and now I'll go side to side also, and you'll see it's a much longer sweep. Anyways, again, set in the middle there, and I reduce the laser current again till it's barely lasing, and again adjust my knobs to get it. This is the top knob. And you'll see a whole, if you really look carefully, see a whole number of flashes as I'm also changing the path length a little bit. And anyways, get the laser somewhere centered around there so you get at the lowest threshold current. Okay, and as I'm adjusting this and setting it for the minimum current that it just lazes at, I'm at the same time, I'm also monitoring the current monitor point with my voltmeter, and I sort of recorded that number. And this laser has a threshold current of about 30.7 milliamps, and that reads at 3.07 volts on my voltmeter. Okay. All right, I'm back again. The next step is to tune up the vertical position of the grating to be on the rubidium 780 nanometer line. And the first step to do that is to do a little bit of electronics. I've got the ramp generator, I've got its output going into the piezo controller here. I'm triggering my scope, which is up here on the synchronous output, and I've also got a monitor from the piezo controller looking at the scope. It's a little hard to see the scope screen there, but we'll show you that in more detail later. Okay, and if I look at the video screen, I should be able to see that the laser is flashing because I'm sweeping the grating angle, which changes the feedback, and it's going above and below threshold as it goes in there. And you can change the frequency if you want and see it blink faster or slower. Okay. All right. I've now also changed the optics around a little. I've got the laser beam coming out of the laser and hitting a wedged beam splitter that's directing it to a cell there. And I have sort of 2 dots through the cell, and you can check on the other side and make sure you've got 2 dots coming out the other side there. I've also, let me get this centered, stuck an Allen wrench in the back here with its end. It's a little hard to see sticking up in the air, and that gives me a reference point so I can always come back. So that gave me my minimum threshold current, and I can always come back to my starting point as I do a search for the rubidium line. Okay, searching for the rubidium fluorescence then. We have 2 parameters that we really have to set that are unknown, and one is the grating angle, which I will adjust by moving this side knob here, and the other is the laser current, which I will adjust on the electronics controller. And I'm going to start at something around 35 milliamps, 3.5 volts. And let me get this set again. Just to a search. And so you're looking for a flash on the video monitor. And I'm going sort of plus or minus half a turn each way and coming back to 0. And now I'm going to increase the current by about 5 milliamps up to 40 milliamps or so. And I'm going to stop switching there and again do a search. So sweeping forwards and backwards. You'll see some light flashing as the laser is just reflecting off the sidewalls. That's not what we're interested in. And so now I'm up at 45. You don't really know to begin with where it's going to first start to fluoresce. Again, you're seeing some just the laser hitting off the side there. And I'm continuing to increase. I'm at 55 milliamps, which is a little high, but that's where this laser just hit up. And did you see that? So there is the fluorescence going. It's rather slow because I had my scan down kind of slow. But there it is fluorescing, and now you can adjust the laser current to sort of make that maximum or minimum. But that's the hard part. Our laser is tuned up, and we're hitting the rubidium fluorescence line. And now it's time to put the photodiodes and look at the spectrum. So I'll be back in a minute. Alrighty. I've now added a detector to the back here, and I've got one of the 2 laser spots going right into the detector. I've adjusted the electronics, and yeah, it's a little confusing here. Anyways, I've plugged in the detector and I have it going into one side of this differential amplifier, and I have the output of that going to my scope onto channel 2, and I've just moved my scope onto the table so it can be next to us and we can look at it here while I adjust things. Okay, and so here's a shot of my scope screen. I've got my laser diode. There's no attenuation in the laser beam. It's just a straight beam. Well, it gets attenuated by the piece of glass that's acting as the wedged beam splitter there. But it's mostly most of the power is going right in there. And part of the problem is this sort of saturates the rubidium line. At the moment, I've got the detector gain set to 10 k ohms, and I'm seeing sort of maybe a division of absorption out of 3 divisions, so sort of 33% or something absorption level. So now I'm just going to add the neutral density beams splitter into the mix here, so attenuate the signal somewhat by sticking that in. Oops. And making sure it's roughly in the middle of the beam. And that reduces my signal level quite a bit, but I'm going to increase the gain of the stop. Okay, I've added the neutral density beam splitter to the setup. I changed the gain of the photodetector, which you can't really see back there, to 100K, and now you can see my scope shot. I'm getting a much higher absorption, about, yeah, it's still a little bit hard to see. We'll focus in on that a little better later. Yeah, channel 2, it's about 2/3 of the signal is absorption signal. So a nice strong signal to try and look at. And now the thing I'd like you to do is to play with the current knob. So as I change the laser current, you can see how that changes the spectrum and moves the modes around and changes it all. And let me get it centered back here. The other thing to point out is I'm getting a mode hop right here. So I'm sweeping through one of the external cavity modes, and then at mode hop, and I sweep through the other one. And if I change the piezo voltage, I can find more and more of those. Well, I've run out of piezo voltage. It's too late there. Anyways, if I go in the other direction, I can find that pattern repeating again. Again, the same pattern, a mode hop, and it repeats again. And there's 5 or 6 of these modes total inside there. And it's important to sit in the middle of this whole mode pattern. And the way I'm going to do that, let me back off a little bit here, as I watch on screen, is to change this side knob very gently. So I've now got my Allen wrench in the side knob sticking up vertically, so I can move it very slowly. And now I'm going to move this, and you can watch the pattern change on the screen, and you've got to be very gentle. So I've gone way too far already. I'm going to come back. There's a little bit of crud there. This is not it's not the most best aligned laser here, so the modes are a little bit spread out. So there's one mode pattern. We'll call it 2 and 3, 4, 5, and 6, and then it all sorts of goes away. So you just want to find the center of that. So 1, 2, and 3, and that is about the middle of it. And right, I'm changing the laser current again to see what it looks like. Anyways, we're now centered on the center of the middle of those external cavity modes. Okay, I'm now ready to set up to do a simultaneous piezo scan and current scan at the same time. And this is well discussed in the manual. So I take a signal from the ramp generator, and not only does it go into the piezo modulation, which is set at full scale, but also into the current modulation input over here. And then excuse me, screenshot of our scope, and now I'm just going to increase the modulation attenuator up to about half scale, maybe a little bit more. And yeah, there's all sorts of crazy patterns on the scope now. And now it's a matter of getting this phase relationship between the internal and external cavity set. And so I'm going to reduce the laser current a little bit and change the piezo voltage, and that's it. And now, right, as you change things around, you'll find you get extra modes, extra patterns. I'm just moving the laser current around. Mostly this is just a function of you having to play around to get it working right. But when you do, you get a nice, pretty picture there of the 4-line pattern. And yeah, that's you can spread it out if you want or whatever. And that's it. Okay.